Hello, good evening guys. So this is the session for laws of motion, PYQs and very good question session. Okay. So today we are going to discuss most important 40 questions from this chapter. Okay. So are you ready guys? So let's solve it. Okay. Cool. Chaliye. So question number 1 is saying this, that there is a bar of mass m, okay, and there is force which is being applied at certain angle theta. Theta over here is given as cx and the value of c is 10. Okay, correct. So they are asking what will be the velocity of the bar when angle will become 30 degree for the very first time. Okay, so basically we are dealing in laws of motion, but we can also take help of work per energy. Okay, so we can write work done by this force is nothing but change in kinetic energy. Initial kinetic energy is 0. So work done by this force, because it's a variable force, right? Theta is changing, so we have to use the integration. It is f into s into cos theta. So can we write f cos theta into dx equals to half mv square. Okay, f can be written as mg by 9 into cos theta, which is 10x dx, correct, half mv square. Okay, we can take mg upon 9 common. Okay, so cos 10x dx will be half mv square. Okay, so because pink color won't be visible right now, so I am using blue color. Getting cancelled out, g we can take it as 10. Okay, integration of cos 10x dx, it will be sine 10x upon 10, and the limit, it is from 0 degree to 30 degree. Okay, remember that 10x is nothing but theta only, correct? So instead of 10x over here, we can also replace it with theta, right? And we can write down the limits of theta, correct, equals to v square by 2. 10 getting cancelled out. Okay, so when we will put the value of sine 30 degree, it will be half. Sine 0 is 0, so it will be 1 by 2. This value, this is 1 by 9, and it is v square by 2. So this is getting cancelled out, right? So v from here, it is coming out as 1 by 3 meter per second, and we can write it as 0.33 meter per second, right? Correct. So let's see which city we should land. So we should definitely go to Agra. Are you getting it? Yes, correct. So now answer for first one is Agra. I. Question number 2. Okay, so there is this wire whose equation is given as y equals to x square upon a. Yes, okay. They are asking what is this height y such that that guy will be in equilibrium. Okay, so over here at every point angle is changing, theta is changing, correct? Yes. So can we say this, that let's say there would be certain angle theta over here, if this is mass m, right? So we know there will be something mg sine theta over here, correct? Okay, and there will be mu mg cos theta over here, right? So from where theta is, this is theta, correct? Okay, so we have done the component as we usually do in NLM and friction. You guys already know this, right? So down the incline it is mg sine theta, up the incline it will be mu mg cos theta. Friction is taking the maximum value, right? Okay, so let's equate it, and when we are equating it, what is the value of tan theta that is coming? So we can say tan theta is coming out as mu. Okay, so but problem is there, every theta over here, when we are moving, theta is variable always, right? So what theta we should take, correct? So we will take the help of calculus, correct? We will differentiate this guy. So dy by dx, it will be nothing as tan theta, correct? And it will be 2x upon a. So the value of mu is 2x by a. Carefully, please put the value. I'm using the blue color. So x is coming out as a mu by 2. Okay? But we have to calculate this height, right? This y. So we can put this x in the equation and we can get the value. Yes, correct. So y equals to x square upon a, or a mu by 2 chi square upon a. So it will be a square mu square upon 4a, which will come out as a mu square by 4. Okay. So which city we should go? This time we should go to Calcutta. Yes? Chaliye. Cool. I hope you are learning something new from every question, right? Okay. Question number 3. So half a kg of stone is there, which is tied to a string of length 1 meter, is railed in a vertical circle with the help of with the other end of the string at the center of the circle. Okay, the angular frequency is 4 radian per second. What is the tension in the string when the stone is at the lowest position? So it's very easy question, right? Correct. If it is rotated with omega, correct, how many forces will be there? Mg will be there, tension will be there, and Mr omega square will be there. Okay, so they are asking the what is the value of tension. So tension, clearly at the lowest point it will come out as Mg plus Mr omega square. Yes or no? Let's put the value. So it is half a kg means 0.5. So Mg, it will become 5. This is 0.5. Length is 1 and the radian over here is 4. So square of that will be 16. So it will become 8, right? 5 plus 8. So answer will be 13 Newton. Are you all getting it? Yes. So answer will be Delhi. Correct? Chaliye. Question number 4th. A rough incline BCE. Okay, if you can see this. This is rough incline BCE. Okay. Whose height is given, that is 25 upon 6 meter. That's great. Okay, block on a rectangular wooden block ABCD. Yes, it is placed on that, no worries. And the height of block is 10 meter. We can clearly see this. A small block is allowed to slide down from the top E of the incline. Okay, the coefficient of the friction between the block and the incline is 1 by 8. So mu over here is 1 by 8 and the angle of the inclination is sine theta equals to, you can see it, that is 3 by 5, right? So theta over here is how much? 37 degree. Okay, that's it. If the small block finally reaches the ground at point F, then dF. So basically they are asking us what is the value of range. What is this value? Range. Okay, correct. Let's calculate it. So when it will slide down like this, correct, g sine theta, that is the acceleration downwards, but acceleration due to friction will also be there, which will try to stop it. So do we know that when on a rough incline, when object slides down, what is the acceleration? G sine theta minus mu g cos theta. Yes, correct. So that is the acceleration, g sine theta minus mu g cos theta. Okay, so let's quickly calculate it. G sine theta, that is 10 into 3 by 5 minus 1 by 8 into 10 into 4 by 5. Okay, so this value it will come out as 6. Carefully we have to do it. This is 2 and this will get cancelled out. So acceleration is coming out as 5 meter per second square. Okay, how much distance we have to come along this? We can calculate it. Okay, so we can calculate the slant height or the hypotenuse over here. Correct. So this is 25 by 6 meter and angle over here is 37 degree. So clearly if this thing it is x, so can we write x sine 37 degree equals to 25 by 6. So x into 3 by 5 equals to 25 by 6. Yes or no? Correct? So we can write it as 1. Anyhow, can we calculate? No, there is no way. Few things are cutting. No. So x is coming out as, bole bhai, 18, 125 upon 18. Okay. We hope that a very good number will come out from here. Okay. Chaliye. So what will be the velocity when the particle will slide from the topmost point to this point? Okay. So what will be this velocity? Let's firstly calculate it. Okay. So we can use v square equals to u square plus 2as because acceleration is constant. Yes or no? Correct. So final velocity we have to calculate. This is 0, 2 into 5 into how much bacha? 20. Ayyo 125 by 18. Correct. Okay. So there is no hope. This is 9. Acha, there is hope actually because it is becoming 625 by 9. So V will be, wow, okay, it's a nice value, 25 by 3 meter per second. Okay, correct. So if V is this, then height of the tower is 10 meter. If you can see it clearly. So basically, this is the height of the tower, okay, and which is 10 meter, and our object, it will move like this, V, okay. So it was coming from here. If this is 30 degree, correct. So can you see this, that it will also be 30 degree, correct. Draw the angle carefully, then only you will get it, right? Correct. So we can say what is the range? Range is nothing but ux, which will be v cos 30 degree, and what is uy? It is v sine 30, correct. Okay, so we can put the value, which is 25 by 3 into root 3 by 2, khach. So it's a very, this value 2 root 3, okay, and this value over here is 25 by 3 into 1 by 2, which is 25 by 6 meter per second, correct. Yes. Okay, now we know what is the range. Range is nothing but ux into time of flight. So range is ux into time of flight. Let's calculate time of flight separately. Okay, so over here, time of flight is, in this case, it is negative uy plus under root uy square plus 2gh. If you can remember the formula. Yes, we should always remember the formula of the time of flight when we throw something from the tower at angle, right? Correct. Yes. So it will be 25 by 6 with negative sign plus under root, it will be 625 upon 36 plus 2 into 10 into 10, correct. Is it a good number? This is 200, okay, and let's upon 10, okay. So without wasting time, let's calculate that. It is 200, right? Okay. Root of 217. 14.73. If we can Root of 217, it is 14.73. Okay, let's subtract this. It is 10.56 upon 10. So it is approximately 1 second. Okay, so the time of flight is approximately 1 second. Okay, we can solve it, and after that we can put the time of flight over here. So ux, it is 25 by root 3, correct? Okay, now I know what mistake I have done. Ayyo, a very dangerous mistake. This was angle 37 degree. That's why all this weird kind of answer was coming. Yes, let's do it one more time. No worries. Correct. No worries, no worries. This is this, which is 10 meter high. Okay. This is 37 degree. And V is 25 by 3. V. We can see this. If this is 37, this is also 37. Okay. So it will be V cos 37, which will be 25 by 3 into 4 by 5. Okay. So at least few good numbers. 20 by 3. And from here, this is V sine 37, which is 25 by 3 into 3 by 5, kach kach. So that will be just 5. Thank you. Now these numbers are looking nice. Okay. So range will be nothing but ux into time of flight. So let's calculate time of flight separately one more time. Okay. So time of flight is minus uy plus under root uy square plus 2gh upon g. So that is minus 5 plus 25 plus, now it is coming very good. Okay. So that is 225, which is 15, negative this is 15 upon 10. So when we solve it, this is perfectly coming out as 1 second. Thank you questioner. Ux, it is 20 by 3 and time of flight is 1. So range will be how much? 20 by 3 meter. Range is 20 by 3 meter. So answer over here, it will be how much, bacha? Del. Correct? Yes. Okay. Let's do next question. Question number 5th. Chaliye. Two touching blocks A and B are placed on an incline forming an angle 60 degree with the horizontal. Okay. Let's draw it. Okay. There are two blocks touching each other. The masses m1 and m2 and the coefficient between the inclined for the two blocks are this and this respectively. The force of reaction between the blocks during motion. Okay. So clearly they are trying to say something. If lesser is the mu, then more will be acceleration. We know this. Okay. Because acceleration is g sine theta minus mu g cos theta, right? So if lesser is the mu, more is the a. So basically, who should be at behind? See, if from these two blocks we have to choose, right? Correct. If m2 is behind, then that is perfect. Then only they will move together. If m2 is ahead, then its acceleration is more. They will leave the contact, right? So basically m2 should be at last and m1 should be over here, right? correct? Okay, so friction for M2, it is 1 mu, that is mu only, and for this guy it is 1.5. okay, now they will move together. The force of reaction between the blocks during the motion is, ठीक है, कोई दिक्कत नहीं. So as they are moving together, can we write कि net force on both of them, it will be m1 plus m2 into g sine 60 degree, correct? Okay, frictional force will be because of both of them, so it will be 3/2 mu m1g cos 60 degree, correct, plus mu m2g cos 60 degree, correct? Okay, so now we can calculate the common acceleration. What is the common acceleration? It will be, let's use blue pen, F net equals to ma, so it will be m1 plus m2 g sine 60, which is root 3/2 minus, can we take few things common? Yes, we can take mu g cos 60, which is 1/2 common, and inside we will be left with 3/2 m1 plus m2 equals to m1 plus m2 a, correct? So this is the acceleration, very weird kind of acceleration, but we have to deal with it. Okay, chaliye. So a is this. If we can, no, we cannot just cancel out m1 m2, right? So we can calculate a from here. A will be this, which is m1 plus m2. So g and this will get cancel out, right? At least few things are cancelling. 10 and 2, that is 5. So 5 mu 3/2 m1 plus m2 upon m1 plus m2, correct? Yes, chaliye. Now we have to calculate frictional force between them. So if we can draw the FBD of m1, this is the FBD of m1, force over here is m1g sine 60, frictional force over here, it will be 3/2 mu into m1g cos 60, and additionally there will be one dhakka or the normal force over here, right? Correct. So clearly by putting the values we can get the answer. Yes, so can we write m1g sine 60 degree plus n plus n minus 3/2 mu m1g cos 60 degree equals to m1a, right? So when we put the values we will get the answer. So it will be little messy, right? But everything is correct over here. So after putting values, after solving it, okay, so n should come out as what? It should come out as this, Delhi. Okay, it's a little messy equation, but I hope that you will solve it, right? It's nothing for you, just peanut. m1 m2 upon 4 g, m1 m2 upon 4 m1 plus m2 into g, correct, into mu. Yes, so this is the answer. Okay guys, ठीक है, चलिए. Just the equation was little messy, otherwise it's a very easy question concept wise. So questions of means, they will be easier very concept wise, but calculation wise few of them will be little lengthy. Okay, cool. A triangular prism of mass capital M, ठीक है, and a block M is placed on it, is released from rest on a smooth plane of inclination theta. The block does not slip on the prism. Okay, both of them are moving together. Then, ठीक है, the acceleration of prism is g cos theta. Okay, let's solve it. This guy is not moving, huh? Small m is not moving. So this small m is not moving. Okay, let's say we know that why it is not moving, because friction will be there on this m, otherwise it will move, right? So there should be some friction force between this capital M and small m. We know this. Okay, can we guess this incline is smooth as given in the question? No worry about it. So clearly, if both of them are moving together, can we assume it is a same mass? So acceleration over here, it will be g sine theta, correct? Okay. Now, if that guy is not moving, the small guy m is not moving, then can we write m is this? Okay. There will be, if we are sitting over here, and watching this, there will be a pseudo force. And what will be pseudo force? It will be mass of this and acceleration of this in the opposite direction. So that will be mg sine theta. Yes or no? Correct? Yes? ठीक है. Okay. And because both of them are moving together, correct? So this pseudo force will try to move it over there. So frictional force, it should be in this direction. Yes or no? In the forward direction. Correct? This guy will try to move it along this side. So friction, it is between the surface and it has no choice. It will be in the horizontal direction. Yes or no? Correct. Okay. So if we can take the component, if that is theta, we can clearly say this is also theta. Correct? So one component of it, it will be over here, mg sine theta square, it will become, and over here it will be how much? Mg sine theta cos theta. Correct? Okay. So if it is not moving, okay, can we assume it as, firstly let's read the options so that the minimum coefficient of friction. Okay. Okay. So F over here we can assume it as mu n, and n clearly we can say that it will be mu into, over here it will be mg. Correct? Okay, so n we can write it as mg minus mg sine square theta. Correct? Okay, so friction we can write it as mu n, which will be mu into mg, we can take it as common, 1 minus sine square theta. Okay, 1 minus sine square theta will become mg cos theta. Correct? Okay, so the friction is coming out as this, and it has to balance this force, which is mg sine theta cos theta, right? So friction should balance mg sine theta cos theta. friction is coming out as mu mg cos theta. Please, please, please. It should be a very good number. It is looking that it will be a good number. Yes, correct. Oh, wow. Oh, it is cos square theta. So sorry for that. It is cos square theta. So over here it will be mu cos theta equals to sin theta. So mu will be tan theta. Okay, correct. Yes. So answer over here, it should be the minimum coefficient of friction between the block and the prism. It should be this. Otherwise, they will slip. Correct? Yes. I hope you have understood it fully, right? So a beautiful application of pseudo force, right? Correct. Okay. A particle of mass m is suspended from a ceiling through a string of length L. The particle moves in the horizontal circle of radius r. The speed v of the particle and the tension T in the spring is. Okay. So let's say this is theta, which is unknown. Let's say this is T. Mg is downwards. Okay. It is revolving in a radius r. So over here it should be mv square upon r. This should also be theta. So we can write T cos theta equals to mg, first equation, and T sin theta equals to mv square by r. Remember, L is also given over here, है ना? L is also given over here, correct? Yes, ठीक है. So if we want to, can we divide 2 by 1? So it will be tan theta equals to v square upon rg. Okay, so from here, if we can make the triangle, this is theta, this is r, this is L. So this will be under root L square minus r square. So clearly tan theta from here, it is r upon under root L square minus r square. So velocity, we can write it as v equals to rg tan theta ka root. Yes, so it will be rg, and tan theta is r upon r square minus L square to the power 1 by 2 and root over it. Okay, so let's see the options. R can come out, yes, so R can come out, and G upon L square minus R square to the power 1 by 2 to the power 1 by 2. Correct? This should be the answer for V. Are we getting any such answer? Correct. This or this. Correct? This is wrong, this is wrong. Either B or answer D. Now clear picture we will get of the correct option from the value of T. ठीक है? चलिए. So can we write T cos theta equals to mg? Is m there in the expression? Yeah, m is there, right? That's great. So T will be mg upon cos theta. So from here cos theta, it will be nothing but under root L square minus R square upon L, right? So mg divided by under root L square minus R square, and L will go on top. So tension will be mgl. I'm writing in the same style that questioner wants us to write. T is this, and we can write V in style as well. So it will be R G to the power 1 by 2 and L square minus R square to the power 1 by 4. So I hope this should be the answer, and we are matching this answer, I think, in option D. Okay, correct. Chaliye. I hope you have understood the entire formula and entire question easily, right? Correct. Let's go to question number 8. A coin of mass 10 gram is placed over a book of length 50 centimeter. The coin is on the verge of sliding when one end of the book is lifted 10 centimeter up. The coefficient of static friction between the book and the coin. We have done this experiment in the class only, right? Correct. So let's do it one more time. We know when it happens, when theta becomes the angle of repose, and when it happens, when mu takes the value tan theta. Correct. Okay, so if this length is L, which is 50 centimeter, okay, and this height is 10 centimeter, correct, and if this is theta, correct, we know angle of repose cut tan theta, it is mu, so mu will be tan theta, and if it is 50, it is 10. Can we calculate this base? Obviously we can calculate this base, so it will be 2500 minus 100, 2400, correct? Yes, okay. So tan theta will be 10 centimeter divided by 10 root 24 centimeter. So it will be 1 upon under root 24. Under root 24 can be assumed as under root 25. So we can approximately write it as 1 by 5, and approximately we can write it as 0.2, right? So answer over here, it will be Delhi. Question number 9. A small coin of mass 40 gram is placed on the horizontal surface of a rotating disc. The disc starts from rest and is given a constant angular acceleration to. Okay, we can write few data. Mass is 40 gram. If needed, we will write it as this, or 4 into 10 power negative 2 kg. We should always write everything in SI unit. Yes, so this is given as 2 radian per second. Okay, then what? The coefficient friction between the coin and the disc is 3 by 4, mu is 3 by 4, and the coefficient of kinetic, this is static, and kinetic is 1 by 2. Okay, the coin is placed at a distance r equals to 1 meter. R is given as 1 meter. Okay, sorry, R is given as 1 meter from the center of the disc. The magnitude of the resultant force on the coin exerted by the disc just before it starts slipping on the disc. ठीक, ठीक, ठीक. So the net force from the disc, that is what they are asking. So if this is a coin, ठीक है, so let's make top view or drone view. Okay, so this is our disc, this is our coin. Okay, the net force by the disc on this guy, firstly there will be N, which will be coming out of the plane of this disc. Yes, and its value will be mg, correct, or N can be written as n is coming out, and n can be written as mg. It is coming out of the plane, okay, where friction will be applied. Friction will be applied. See, it has to make it go like this to provide the force, okay, and there will be centrifugal force as well. So friction will be applied somewhere over here, and we do not care in what direction it is applied, although we can calculate it, okay. So these are the two forces which are applied by the disc on the normal. There is no third force, correct, because resultant of this and this is friction force. Friction is balancing the tangential force and the radial force, okay. So correct, friction will be in this direction and this is the net force, right? So friction, correct. If it is on the verge of slipping, then friction will take value of mu as mg. Are you getting it? Okay. And you can see normal and friction, they are perpendicular to each other. Why? Because friction is in the plane of disc and normal is coming out, so they are actually perpendicular to each other. So F net on coin due to disc, it will be under root n square plus f square. So it will come out as mg square plus mu s mg square, okay. So it will be mg will be freed like this, and this is 1 plus mu s square. So we just have to calculate it. I think we know the value of m, which is 4 into 10 power negative 2. So 4 into 10 to the power negative 2 into 10, and the value of mu s, it was how much, guys? 3/4. Barobar. So it is 9 upon 16. So when we calculate, it's a very beautiful number, 5/4. Okay, and it is 4 into 10 power negative 1. So 4 getting cancelled out, it is just 0.5 Newton. A very good number, very good number. Thank you question. So answer over here, it should be Delhi. Which question is this? 9th. Okay, correct. So answer over here, it should be Delhi. Correct, guys? Okay. Question number 10th. An inclined plane is bent in such a way that the vertical cross section is given by this. Okay, we have done a similar question. Okay, is given by this. Okay, if the upper surface of curve is rough with coefficient this, the maximum height in centimeter which a stationary block will not slip down is. Okay, so we can write clearly, guys. Over here it will be, because this was the first question I think of the session that we have solved, it is mg sine theta. Over here it will be mu mg cos theta. So mu will come out as tan theta, yes or no, and tan theta is nothing but dy by dx. Okay, so mu will be what? Dy by dx will be 2x by 4, mu is 1 by 2, so 2x by 4 khatam. So it is this. So x is coming out as 1 meter. If x is coming out as 1 meter, so we can put that by x over here, and y will be 1 square upon 4. So we will get that height. Y is 0.25 meter, or they are asking in centimeter, so it is 25 centimeters. So answer over here is 25 centimeter. Correct? Yes. Question number 11th. An insect crawls up hemispherical surface very slowly. The coefficient of the friction between the insect and the surface is 1 by 3. Okay, so mu is 1 by 3. If the line joining the center of the hemispherical surface to the insect makes an angle alpha with the vertical, the maximum possible value of alpha is given by. Okay, So again, same kind of thing, guys. Okay, if we can say this, if this is alpha, carefully draw and use chakra method. Do you remember chakra method? Everyone remembers chakra method. Okay, so if that is alpha, we can say this is alpha, this is mg, okay, this is normal, friction will be over here, okay. So this is exactly mg sine alpha, exactly like incline, and this will be mg cos alpha. So value of n is mg cos alpha. The friction should take the value of mg sine alpha, and the value of friction is mu n, which is mg sine alpha. Yes or no? So mu mg cos alpha equals to mg sine alpha. Yes or no? So that it won't go anywhere. So from here we can clearly say mu equals to how much? Tan alpha, okay, and the value of mu is 1 by 3, so the value of tan alpha will be 1 by 3. So value of tan alpha will be 1 by 3. Over here tan alpha is not given as 1 by 3, so let's reciprocal it. So can we say that 1 upon cot alpha is 1 by 3, so cot alpha is 3. So answer over here it will be Agra. ठीक है, चलिए let's go to next question. Okay, question number 12. Spring has natural length L. This is natural length L. With one end fixed to the ceiling, the other end is fitted with a smooth ring which can slide on the horizontal rod fixed at a distance L below the ceiling. We can see that. Initially, the spring makes an angle 60 degree with the vertical. When system is released from rest, the angle of the spring with the vertical. Find the angle of spring with the vertical when the velocity of the ring reaches half of the maximum velocity which the ring can attain. Okay, we know over here there is this maximum extension, it will become minimum at this point. So at this point over here we will have maximum velocity, right? So can we calculate that maximum velocity first? Let's do it. Okay, so can we calculate on the new page so that you can have a nice view? This is L, this angle is 60 degree. Okay, so clearly this value will be x cos 60 is L, so this value is 2L, correct? Let's say this is x cos 60 is L, so x by 2 is L, so this length is 2L. So over here we can say initially x initially, which is extension, it will be L. Okay, so when this spring will reach over here, correct, the particle will attain Vmax. Okay, so can we calculate that Vmax first? Okay, chaliye. So we can use the conservation of mechanical energy and calculate that Vmax. आइए, so Ui plus Ki equals to Uf plus Kf. Okay, so initial kinetic energy is 0, final potential energy is 0. Why final potential is 0? Because L is the natural length, right? So if we can write x final is 0, okay, because spring is at natural length, correct? Okay, so initial potential energy, it will be half k x square, which is half k L square equals to half m V max square. Okay, so Vmax, it is coming out as 6 under root K by M into L. That is Vmax. Okay, cool. Okay. Now we want to calculate what is the angle from the vertical when object is somewhere where its velocity is half of it. Okay, so Vmax, I should use different color of pen. Vmax by 2, it will be L upon under root K by M upon 2, right? Okay, so can we calculate extension at that point? Let's do it. So again we will use Ui plus Ki equals to Uf plus Kf. So initial potential energy is half K L square, initial kinetic energy 0, final potential energy we want to calculate. So can we write it as half K x square plus half M into square of this. So it will become L square K by M and 2 will become 4. So it is coming out as M getting cancelling out, KL square by 8. Okay. So if we can calculate it, it will be 3 by 8. 3 by 8 KL square equals to half KX square. So KK will get khalas. This will be 2. So X is coming out as root 3 by 2 L. Okay, this is the extension. Okay, we know that the length of the spring was L. Okay, if we can add it to length, okay, just want to make sure that I have done everything correct. Otherwise, yeah, half KL square plus 0, half KX square, half into KX square. So half mv square, half m into L square by 4 K by M, khach khach, that is perfect. KL square by 8, so over here 4, 8, correct. So khach khach, that is 3, that's perfect. Okay, so X is coming out as this, very good. So the final length, it will be L final will be L plus X, that is L plus root 3 by 2 L, right? That is L final. Okay, so how will that particular diagram might look like? It might look like this, that this length L final L final is L plus root 3 by 2 L, and if this is theta, correct, can we write LF cos theta equals to L only, right? So it is L, take it as common, 1 plus 3 root 2 into cos theta equals to L. Okay, so LL getting cancelled out. It's a bizarre kind of answer. 2 upon 2 plus root 3. So theta should be cos inverse 2 upon 2 plus root 3. Do we have something? Ah, kya baat? It is Bombay. Okay. 12th. It is coming out as cos inverse 2 plus 2 root 3. Yes. Okay, let me check. we made some mistake. Let's see one more time. They're asking theta from vertical only, right? With the vertical only. ठीक है. This is perfect. Half k L square equals to half this thing. Okay. Now V is V max by 2. So this is the thing, correct? Half kx square plus half. Let's solve it from here. Apparently we are getting little different answer. So let's solve one more time. So half mv square. So v is this clearly. So 4 will come, L square k by m, right? Okay, mm getting cancelled out. Half can also cancel out. Kl square equals to kx square plus kl square by 4. K cancelling out. So okay, three L square by 4 okay, getting still the same answer, Anna. If we can do this, if I can apply ui plus ki plus uf and kf from this point, let's say here v max and here v max by 2. Okay, this is theta, this is L we know. Okay, let's apply it from here to here. This is initial and this is final. Okay, ठीक है. So if we are applying from here to here, this length, let's say it is h. Okay, and h will be nothing but L plus x. Why L plus x? Because correct, x is the extension that we are taking. So if this is initial, this is final. Let's do it one more time. Ui, which is half k x square, initial kinetic energy half m v max square by 4 equals to potential energy will be 0 and kinetic energy will be half m v max square. Okay, ठीक है. So let's cancel half like this. Kx square will be 3 by 4, correct? V max square. Okay, so V max square, it will be this L square k by m, and this is kx square, k getting cancelled out. Okay, where is m? M was also there, so getting cancelled out. So x is root 3 by 2l, still coming the same. Yeah, still coming the same, correct? Okay, so we can write h equals to L plus x. So that is L plus root 3 by 2, that is h. Okay, and h cos theta equals to L. So L into 1 plus root 3 by 2 cos theta equals to L. L getting cancelled out. Cos theta is coming out as 2 upon 2 plus root 3, right? So theta is cos inverse 2 upon 2 plus root 3. Yeah, I will go with B. Correct? We have done enough. Okay? Correct. That is correct answer. Question number 13th. Block A of mass m and block B of mass 2m are placed on a fixed triangular wedge by means of massless inextensible string and a frictionless pulley as shown in the figure. The wedge is inclined at 45° to the horizontal on both sides. The coefficient of friction between block A and wedge is 2/3. Okay, and over here it is 1/3. So clearly acceleration will be like this. Okay. If the block A and B are released from rest, find the acceleration of A. Okay. Correct. So can we write 2 mg, because friction in both of the cases it will be in this direction, right? This is friction 1, this is friction 2, so opposite to them only. So can we write 2 mg cos theta minus 2 mg sin theta minus f1, which is mu 1/3 into 2 mg cos theta minus, because mg sin theta will be over here, minus mg sin theta minus mu, which is 2/3 mg cos theta equals to 3ma, right? So from here we have to calculate A. M getting cancelled out, so it is G, we can take it as common, so that is 2 sin theta minus 2/3 cos theta minus sin theta minus 2/3 cos theta upon 3, right? It is A. Remember, over here theta is 45° only, so sin theta and cos theta, they are same, so we can either write in any format, right? So we are writing in sine format, so G into 2 sin theta 3 sin theta minus this, so 3 sin theta minus 4/3 cos theta upon 3, right? So it will be 3 9 5 9 5. We can write either sin theta or cos theta because values are same, correct? That is 10 equals to A. So अच्छा जी. So acceleration, it is coming out as, is it coming out as positive, negative? I'm idiot. I have lost my mind. 2 sin theta, so that is sin theta only. sine theta minus 4 by 3 cos theta into g by 3. So answer is coming out as negative. Okay, so it means what? Answer negative cannot come. Why answer negative cannot come? Because if they can slip over here only, but answer is still coming as negative. It means objects are not moving. Okay, correct. The upper half of an inclined plane of theta is perfectly smooth, while the lower half is rough. The body is released from rest from the top and comes to the rest at the bottom if the coefficient of friction for the lower half is given by correct. So we will do this with work energy theorem. Okay, here it is rough, here it is rough, and here it is smooth. Let's say this length is L and this length is also L. So if a guy released from here from rest, okay, finally at the bottom it comes at rest. Okay, inclination is given as theta. Okay, so by work power energy, work done by all forces, which is mg plus friction, it will be kf minus ki. So this is 0, this is 0, correct? Initial is 0, final is 0. Work done by mg, if you can see this, it will be mg into 2l sine theta, 2l sine theta, and work done by friction, it will be negative mu mg. The friction will only do work in the blue part, right? Because over here it is smooth, it will do only work in blue part. So it will be negative mu mg just L mu mg, because friction is cos theta, into L equals to 0. So from here can we say something? mg ll getting cancelled out. 2 sine theta equals to mu cos theta. So mu will be coming out as 2 tan theta. Okay, so this is kind of an important answer, because I think that it will come again. There are few other questions like this. Okay, so if we can remember, it's better for us. Okay, chaliye. It is related to constraint. When we will understand constraint, then we can do it. Okay, question number 17. A block of mass 2 kg is initially at rest on a horizontal surface like this. A horizontal force F1 is 6 Newton, F2 is 10 Newton. They are applied. The coefficient of friction and kinetic friction are 0.4 and 0.25 respectively. The magnitude of frictional force acting on the block. Okay, so let's see. If this guy is 6, barobar, in the vertical direction it is 10. This is 10 and this is 6. Okay, this guy is of 2 kg. So mg, it is 20. So normal is this, and value of n, it will come out as 10 Newton. Correct? Value of n, it will come out as 10 Newton. So the applied force over here is 6. At this point, what is the F max? It will be, because coefficient of friction is given as 0.4 into 10, that is 4 Newton. Yes, correct. What is, and Fk max, the kinetic friction max, it is 0.25 into 10, that is 2.5 Newton. So clearly we can see that this block will move, because friction will be in this direction, and the maximum friction that this body can have is static friction if it is at rest. Okay, but if force is greater than 4 Newton, then this guy will move, and as this guy will move, static friction will stop. Which friction will be applied? Kinetic friction, right? So we won't apply this. Okay, we won't be apply this, we will apply this, right? So friction over here, it will be kinetic friction and it will be A. Yes, chaliye. Question number 18th, the coefficient of friction between the two blocks given is 0.4 and between the lower block and it is 0. Okay, the blocks are given velocities of 2 meter per second and 6 meter per second respectively in the direction shown in the figure. In how much time the slipping between the blocks will stop? Okay, so clearly F net, we can see on these two blocks is 0. F net on both these blocks is 0. It means we can conserve the momentum, right? So 2 into 1 plus 2 plus, what I'm trying to write is m1 u1 equals to m2 u2. m1 u1 plus m2 u2. The friction will stop working when they are moving together. So it will be m1 plus m2 into v. Okay. So it is 1 into 2 plus 2 into 8 equals to 3 into V. So answer over here is 16, 16 to 18, 18 by 3 is V. So when V will be 6 meter per second, then friction will stop working because both of them will move together. Relative slipping is 0. So friction will be happy and it will stop applying, right? Okay. So after how much time the slipping will stop? So over here, if we can see this, what will be acceleration? So friction is doing some magical work. Okay, what magical work friction is doing? If this is a 2 kg block, sorry, 1 kg block, and if it is a 2 kg block, so friction on 1 kg block, it is applying in forward direction so that it can increase the speed of 1 kg, and over here it can decrease the speed of 2 kg. Okay, so friction will be mu n, right? Mu is 0.4 and n it is 10, so it is 4 Newton, correct? Okay, so if we are talking about acceleration, acceleration we know it is mu g, so which is 0.4 into 10, that is 4 meter per second square. Okay, we can take the perspective of 1 kg over here and we can write v equals to u plus 80. Final velocity is 6, initial is 2, a is 4, and time we have to calculate. So it will happen in just 1 second. Okay, so answer over here is 1 sec. Okay, chaliye. Question number 19th, a wire bent. So this type of question we have already done, so I would expect that you will also solve this, correct? Yes, chaliye. This question also we have done. I think the upper half of the incline of an inclination is smooth while the other lower is half. So this also we have done. So answer of this, it should be Agra, right? We have recently done this. Okay. Okay, this is related to constraint. Okay, so let's do it after we will understand constraint motion. Okay. Question number 22. Two blocks of mass 3 kg and 2 kg are placed side by side on an incline as shown in the figure. A force 20 Newton is acting on the 2 kg block. The coefficient of friction between the block and the incline is 0.1. Find the normal contact force exerted by 2 kg on 3 kg. Okay? So very easily we can say this, right? These kind of question. If this is 37 degree, we can assume it as 5 kg only. Force that is being applied is 20 Newton. And what else? 37 degree, yes. Okay. We can calculate the acceleration. Friction between them is 0.1, right? So mu over here is 0.1. Okay, so acceleration, it will be mg sine theta minus mu mg cos theta upon m, right? Okay, so it will be g sine theta minus mu g cos theta. Okay, so it is 10 into 3 by 5 minus 1 by 10 into 10 into 4 by 5, correct? So answer will be 6 minus आपका 6.8, that is 5.2 meter per second square. So acceleration is coming like this. So now we want to calculate what is the normal force between these two guys. Okay, so position is very important. Let's consider 3 kg. Okay, so 3 kg is little down over here, 3 kg. So over here it will be mg sine theta, which is 30 into 3 by 5, which is 80 Newton. Okay, friction over here, it will be mu mg cos theta, because they are moving together. Mu is 0.1, it is 30 into 4 by 5, so 12 by 5, so it is 2.4 Newton, correct? 24 to, oh yeah, correct, that is correct. And there will be one more force of normal over here from the 2 kg, and resultant acceleration is 5.2 meter per second square. So can we say this, that 18 minus 2.4 plus n equals to 3 into 5.2. So it will be, n will be 15.6 minus what, 15, I did almost everything correct. It's 15.4, right? So 16, 15.6. Okay, that's great. N is coming as 0. Did I make some horrible mistake? Let's see. 520 okay, g sine theta, g cos theta, so 0.8, 5.2, clearly 5.2, 0.1 into 30 into 4 by 5, 2.4, 6, 18, 18 minus 2.4 plus n equals 3 into 5.2, 15.6, 0.6. Let me check it. This is question number 22. A. I made mistake in A. Oh Lord. Yes, I didn't consider that 20. Worries. Okay, so we can write F net equals to MA mg sine theta minus mu mg cos theta plus f equals to me. ठीक है, so mg sin theta 50 का ये हो जाएगा mg sin theta आपका 30, करेक्ट, minus 0.1 mg cos theta would be 40 plus 20 equals to 5a. ठीक है, तो few mistakes are horrible, they will eat up your time. 50 minus this 46 by 5 is a, we can write in simpler terms 9.2 meter per second square, that is the acceleration. Okay, ठीक है, now we can have our प्यारा 3. So mg sin theta, we just calculated it, it was coming out as 18. Friction, it was mu mg cos theta, it was coming out as 2.4. Let's say this is n and acceleration is 9.2 meter per second. Okay, so can we write f net equals to ma? Okay, so 18 minus 2.4 plus n equals to 3 into 9.2. Now whatever is the answer is correct. 27.6 minus 16, 15.6. okay, so over here it will be 12 Newton. Hit it. ठीक, 22. Let's do question number 23. Okay, so it's very easy question, just the force balancing one, right? Correct? That is 23. So if we can balance out all of the forces, okay, so please do it by yourself. Question number 23, answer over here is Agra. This we do not have to do. This is a kind of a question where we have to apply the series portion of this, x to the power 1 upon 1 factorial plus 2 upon 2 factorial, x power 3 upon 3 factorial, and so on. Okay, so kindly do this. Answer over here is this. Very easy question. Okay, so answer over here is this. Draw it beautifully and you can get the answer. So over here it is C. Very easy question. Okay, so kindly do this as well. Hint that I can give you: do not forget centrifugal force. Okay, so answer over here is Bombay. Question number 30. So very easy kind of question this is. Okay, so its answer is this. You can attempt it. You can also attempt it. One of the easiest portion. Answer for this. So clearly this question is wrong. Forget about this diagram. Okay. Forget about this diagram. So, but answer over here is this. Hint. Okay. Okay, correct. This is the hint. You should attempt this. answer for this is this. Yeah. Okay, very easy question. So attempt it. Answer for this is C. Correct. One of the very easy question of the circular pendulum. So answer over here is A. Okay. So ठीक है. Hint. Draw FPD nicely. Okay. Very easy question. Okay. So okay. So in this session, we did half of the questions, and half of the questions I'm leaving for you to do it. And if you have doubt in those, we can always discuss. Okay? Chaliye. So guys, I think that's all from this session. Thank you so much. Have a nice day.